Yeah, hey guys, this video is going to be titled Expressions, and it's essentially going to just cover algebraic tricks and manipulations so you get comfortable with them. So when you're solving the more complicated problems on the SAT, you don't get caught up or hung up on the little details, on like the calculation detail, or you can focus more on the calculation instead of, oh, did I distribute this right and did I factor this out right? So we're going to be going over 5 techniques, and the first one is going to be called combining like terms. So I know you guys have probably been doing combining like terms probably since middle school, right? I mean, it's you had to first learn that b squared plus b doesn't equal bq, right? Because we have difference in exponents here, um, right? So this is basically pretty much the same thing, but of course, it's your older, you're going to be doing more difficult questions. So let's look at one. So we have 2 times 2a squared minus 3a squared times b squared minus 4b squared. I'm going to move this over. Right, so this is minus a squared plus 5a squared b squared minus 10b squared. Okay, so let's look at this question, right? So it's under combined like terms. We want to simplify this as much as we can. So the first thing we're going to need to do is distribute. So we may as well just start with this 2. We're going to be multiplying this 2 by each one of these. And then for the this on the right side, what you really have is a minus 1 in front. So you're going to be multiplying minus 1 by each one of these. So let's start with the green. So 2 times 2a squared is 4a squared. 2 times a negative 3a squared minus b squared is, of course, minus 6. And then you just follow along your variables. 2 times minus 4b squared is going to be minus 8b squared. Look at blue. Minus 1 times a squared is minus a squared. Minus 1 times 5a squared b squared is minus 5a squared b squared. And of course, minus 1 times a minus 10b squared, that makes it 10 positive. So you have plus 10b squared. Okay, so from here, we're going to want to add up like terms. So let's start with this. We got 4a squared. So we're looking for something else that has an a squared attached. Now, not just attached, I'm sorry, it has the only thing attached to a squared. So we just see 2 of these. So it's going to be 4a squared minus a squared, right? So it's going to be 3a squared, right? So we're done with those. And usually when I'm done with them, I mark them out so I don't get tripped up. Now let's look. The next thing in line is minus 6a squared b squared. So we're just going to look at the variables. That's all we care about. We have a squared minus a squared times b squared. The only other one is going to be this. We're just going to add the numbers in front, right? So it's going to be minus 11 a squared b squared. We mark those out. What's next? So we're going to have minus 8b squared. So the b squared is the important part, and of course the only thing left is a positive 10. So it's just going to give us plus 2b squared. Right, so this is essentially just combining like terms, right? You just want to make sure you're only adding up the terms that have the right type of variables attached. And yeah, that's, like I said, this question in this section is probably one of the easier ones. Just to kind of get this brain juices flowing. So let's look at the next one. So we have 2 times x minus 4 times 2x plus 3, right? What's our first step here? So you want to pause the video and then solve it. You want to just simplify it as much as you can and evaluate it. Okay, so hopefully you guys had a good go at that. So the first thing that I would do is put this 2, distribute this 2 here, and then rewrite the question. So we get 2x minus 8. Now you have 2x plus 3, right? This is something that's probably more familiar to dealing with. So you'll just do your 2x. Oh, that was the eraser. Where's, go back. You have your 2x here, 2x and 2x, and then 2x times 3. And then you'll have minus 8, minus 8 times 3. So 2x times 2x is 4x squared. 2x times 3 is just plus 6x. Minus 8 times 2x is minus 16x. Minus 8 times a positive 3 is minus 24. Right, so now it's the same thing. We're just going to be adding like terms. For this, we don't have any other x squared, so bring it down, 4x squared, cross them out. We have a 6x and a 16x, so that's minus 10x, right? So you can cross those out, and of course your constant, so just minus 24, right? So that's just a simple way of doing it. Probably is a little bit weird if you have a constant here. Just remember, you can pull that, you can multiply and bring that constant in, or you can always pull it out. So we just brought it in and then multiplied it again. But they could very well give you something like this and say, right, simplify this. And in this case, the only thing you can really do is pull this 2 out, and you would get what you started with. So, okay, so there's going to be, when you're dealing with factoring an expression, you have a lot of several key formulas you should know, right? So these you should commit to memory. And if you're like me and not good with memory, I'll show you how you can always just derive them on the spot. But really, they're not too bad. These aren't going to be the worst thing you need to commit to memory for the SAT. So we'll go through these real quick, and this will help you in your classes too. These come up a lot in math. So you have a plus b and that whole thing squared. Well, this becomes a squared plus 2ab plus b squared, right? And this becomes a squared minus 2ab plus b squared, right? And then this just becomes a plus b times a minus b, right? So now we gotta ask ourselves, well, how did you get this, right? Well, let's look at this. We have a plus b squared. It's the same thing as doing a plus b times a plus b, right? Nothing's fancy there. We're just expanding it. So then you're going to distribute your a's, and you'll distribute your b's. So let's do our a's first. A times a is a squared. A times b is plus ab. B times a is plus ba. And b times b is plus b squared, right? So this just simplifies to a squared plus 2ab plus b squared, right? Because it doesn't matter for this, for example, it doesn't matter ab equals ba. It doesn't matter if you can switch around for multiplication, the variables or the numbers. So anyway, so that's how you would get 1, right? So go ahead and try these 2 and 3 for practice. You can practice your distribution just to see. You should get what we get here on the right. Like I said, you want to remember these because these come up a lot in practice and problems. Okay, so let's look at this example. What can this be simplified to? What can this be simplified to? Right? So immediately we see we have 4 x to the 4th minus 9 y squared, right? So we can say this for sure, right? And we can say why. Why is that true? Right? Well, this is because the exponent rules here, right? This 2 would go back to there, and this 2 would go back to there. Sorry, this 2 should be gone, right? So if we did this, let's just look on the left side here. We do 2 squared x to the 4, right? Well, this whole thing, 2 squared is just 4, so it's just 4x to the 4. So we know we can pull that 2 out, right? And similarly, we can pull that 2 out here on the right side. But this is good, right? This looks like something we have up here, right? What do we have, right? What does this look like? This looks like a squared minus b squared, right? If you say let a equal 2x squared, and you let b equal 3y, right? Then a squared is what? 4x squared. Sorry, 4x to the 4. Right? B squared is 9y squared. Right? Well, that's exactly what you have here and here. So what does that mean? That means that this here in my green box is the same thing as saying a squared minus b squared. Right? Because again, we're saying, I'll circle it in red. Right? This thing here in red is a. And this thing here is b. But this whole thing in red is being squared. So you have a squared minus b squared, and we have a formula for that, right? You have a formula for this. It's just a plus b, a minus b, right? So, but now we just substitute what we have in for a. A is what? 2x squared plus what, 3y. And then there's going to be 2x squared minus 3y, right? That's what we have for a and b. Now, if you were to multiply this out really quick, and I suggest you do that so you can see, we should end up with this, right? This is a simplified form, our factored form. This is a factored form of this, right? So let's multiply this out and then come back and check it out. Now I'm going to multiply it out real quick just to make sure we did this right. So we have 4x to the 4. I don't care about that. That goes away. That goes away. This is going to be minus 9y squared. Yep, sure enough, that's it. Okay. Now let's look at another one, right? Let's say we have 16 to the x to the 4 minus 8x squared y squared plus y to the 4. All right, so let's see. We have a minus, we have a 2 squares, we have something that probably could be a square. Let's say we say let a equal, well, this is 4x squared. We let b equal y squared. What's a squared? Right, ask yourself, what's a squared and b squared equal what? Well, a squared equals 16x to the 4. B squared equals y to the 4. So we have something that could be a squared here, we have something that could be b squared here, right? So if we see that, then we know we have a formula that looks something, we have an a squared on the left, we have the b squared on the right, but in the middle we have a minus 2ab. Well, let's see, what's our a? Our a is 4x squared, and our b is y squared. So let's just do it over here on our side, scratch work. Minus 2ab equals minus 2 times a, 4x squared, times b, y squared. That's minus 8x squared, y squared. Well, sure enough, that's that right there. So you have a squared minus 2ab plus b squared, right? What does that equal? That just equals a minus b squared. And what was your a? Your a was 4x squared, your b was y squared, and the whole thing was squared. Right, so that's just another way of simplifying something like this that we're given. So that's combining sorry, that's not combining, that's expansion and factoring, and then you do a little bit of combining like terms. The third thing is much easier than that. It's like you don't have to really remember too much patterns, you just gotta kind of remember the basic math that a lot of us forget if we don't use it. But it's combining fractions. Right? So let's say we're adding two fractions. Let's say we're adding 1/3 plus 1/4, right? The rule is you can't add if you don't have the same denominator, right? So of course this one here is a 3 and this one here is a 4. So you can't add those. What we need to do is somehow get a base that they're the same. And the way you do that is if you have 1/3 plus 1/4, right? You multiply this by a 3 and you multiply this by a 3. On this side, you multiply this by a 4 and this by a 4, right? So here you'll have 4 12s, here you'll have 3 12s, right? So you just basically take the opposite and you multiply it here on top and on bottom. Because 4 over 4 equals 1. So you're not changing the left-hand side, which is 1/3. And similarly for the right side, which is 1/4, right? You multiply by a 3 on the top and multiply 3 by a bottom because 3 over 3 is 1, right? So you're not changing 1/4. So now we have an equivalent fraction, and more importantly, we have the same base. So this, you just add the top, you'll get 7 over 12, right? So now you can do this with variables too. You can do this with x's, x squareds, x plus 1s, whatever you want to do. And in fact, we're going to do one right now. So you have 1 over x plus 2 plus 2 over x minus 2, right? Now it's saying add this, okay, right? So, well, what's our base, right? So it's going to be x minus 2 times x minus 2, right? Over here, we're going to do x plus 2, x plus 2. And again, we do this because this whole thing in red is just 1. It doesn't matter what I multiply by. I can multiply by 1,000 over 1,000, a million over a million. As long as it's the same thing on the top and the same thing on the bottom, it's not going to change this at all. In fact, it'll just make our lives easier because then we can add up. So let's do this side first. This is going to be x minus 2. This is going to be x minus 2, x plus 2, plus this will be distributed to 2, you'll get 2x plus 4 over x minus 2 times x plus 2, right? Now, we can just add the tops, right? We don't really care. We know right here in white, the bottoms are the same, so we can just add the tops and simplify it. So we have x minus 2 plus 2x plus 4, right? Well, this equals, combining our like terms, 3x, 4 minus 2 plus 2. Or you can think of minus 2 plus 4 either way. So now you have 3x plus 2 over x minus 2, x plus 2, right? So you're good, man. You're done. Just remember, if you're given two, and I'll do this abstractly so you can have kind of like a formula to think about. If you have a over b, and it doesn't matter what a or b are, they're just placeholders. They can be variables. They can be x to the cube plus 4. It can be whatever you want. Right, and you want to add these. You need to take d multiplied by d over d, and on this side, and then on this side you need to do b over b, right? Because again, d over d is 1, right? So you don't change that. B over B is 1. Doesn't matter what this is. I mean, of course, if it's 0, you can't do it, but you're never going to have 0 on the bottom anyway, so you don't have to worry about it. Anyway, so if we do that, you would get AD plus BC over BD, right? So this is kind of like the formula way. If you guys want to remember it, just remember you got to get the same base on the bottom, and then you can add them. Okay, so the fourth one is flipping, right, or I guess dividing. That's what we'll be doing. Fractions. Change red. Tired of looking red. Can I get a purple? Yeah. Okay. So now they're saying, like, let's say we have 1/2 over 3. Is this the same thing as 1 over 2/3? Right? Maybe take a minute, ask yourself, come back. Okay. Well, let's see. Let's see if it's the same thing, right? So at the very top we have 1/2, right? And on the bottom we have 3, right? So if you're gonna do your math, you would do 1/3, right? So this is 1/6. So 1/6 is here on the left. What about this? This is 1 over 1 times 3 over 2, or 3/2. So on the right side, it's 3/2. So obviously 1/6 is not equal this, is not equal that. So they are not equal, right? So let's say, how do we get there? Well, if you're given, right, when you have a fraction over a fraction, there's like 3 different cases I can think of off the bat. You have A and you have B over C, right? You have A over B over C, right? Or you have A over B, C over D, right? So we'll go through each one, right? So each one, let's do 1, 2, 3. So 1 is going to be A over B over C. In this case, A is a whole number, right? So I can do A over 1 over B over C. Now what I do is, to simplify this, I bring down A over 1, I leave it alone, I flip B over C, so it becomes C over B, and then I just cross it, right? Then I just do the math normal. So then it would be A times C, 1 times B, or AC times B, right? So again, you turn A into a whole number, you put a 1 underneath it, right? And then your next step, going to here, you're going to bring A over 1 down, just leave it. You're going to flip whatever's on the bottom. In this case, it's B over C. So you flip it, it becomes C over B. Then you just multiply straight across. It's really that simple. I heard some of you guys say before, keep, change, flip. I don't know, something like that. I didn't learn it that way. I just remember you flip it, you keep the top the same, you flip it, and you multiply across. So I guess keep, change, flip. That makes sense. But anyway, so let's look at case 2, right? So case 2 is you have A over B over C, right? Again, so let's see. So you have your fraction on top. You have C on bottom. C is a whole number, so you can do A over B over c over 1, right? That's just your next step, right? The next step. Now what you're going to do, again, you just bring a over b down, right? You flip this bottom with 1 over c, and you multiply it. So you get a times 1 times b times c, or a, b, c, right? So again, you're keeping the top the same, you're bringing it down, you always just flip the bottom, and then you multiply. So you're always flipping the bottom. The top, you just keep. You don't care about doing anything to the top. You just keep it the same. And again, lastly for 3, so I'm not going to go through all the steps because let's just see if we can pick it up this way, right? Because we just, remember, we keep the top. We want to simplify it. We're going to flip the bottom, do C, and you'll get AD, do C. Okay, so anytime you see a fraction, it's going to be one of these 3 cases. And you always keep the top, flip the bottom, multiply across. So let's try, let's see this one. X over 1 over x minus 1 plus 1 over x plus 1. Wow, so this looks messy, right? This does not look nice. But in fact, it's a combination of what we've been doing. So here in green is a combination of fractions, right? So that'll give you a fraction, and then so the whole thing in purple is going to be what we just did, which is you're going to need to flip this fraction. So let's break down what we're doing in green first. So what I'm going to be doing here, I'll be doing in green. So of course, I'm going to do 1 over x minus 1, 1 over x plus 1. I want to simplify this. So I'll multiply this by x minus 1 on the top and on the bottom. And now on the right-hand side, I'm just going to multiply x plus 1, right? So let's see. We'll do this math here, right? This is going to be x plus 1 plus, right? This is where this plus comes down. We'll do this math. This will be x minus 1, right? And then over x plus 1, x minus 1, right? So in this case, let's simplify the top. The top is going to be the 1's cancel out, and you get 2x, right? X plus x. And then you get this bottom, which is x plus 1 times x minus 1. Right, so this whole thing is in fact this in green. Everything in green, we can replace it with this. So that's what I'm going to do now. Because we did all of our work here, right? All of our work here showed us we can just put 2x over x plus 1, x minus 1, right? Okay, so let's clear this way, base here. Again, this was just, right, so you can see how learning the basics of this fraction stuff simplifies things pretty quick. Because now we just have one fraction here, right? So what we're dealing with is a fraction over a fraction. Okay, so let's see. So this is going to be one of our cases. It's actually, in fact, going to be case 1, right? Where you have just a lone thing by itself on top and a fraction on bottom. Well, what's the first thing we do, right? You're going to say, well, when we write this, say x over 1 is over 2x over x plus 1, x minus 1. Right? Now, what do? We bring this guy down and just say, okay, I'm leaving you alone. Nothing to do with you, right? Now, with this, we're going to flip. So what do you mean when we flip? We say, well, x plus 1 times x minus 1 over 2x. And then we just multiply straight across. We're done after that, right? I mean, it's kind of messy. You got a lot of multiplication to do here. But, you know, that's the SAT, I guess. So from here, we'll just multiply it out. You'll get, actually, if we can see this, this is going to be not too bad, right? So you'll get x squared minus x plus x minus 1, you cancel, all times x, right? So this is going to be x cubed minus x, so you'll get x cubed. Actually, we want to leave that x alone, and I'll show you why. So we have this is x squared minus 1, right? This x goes away, right? That's just fraction multiplication, so we have x squared minus 1 over 2. So, yeah, so we took, erase it, but we took that huge problem and we used what we learned in flipping fractions and combining them to really break them down. So, the last technique we're going to learn is really simple, and it's good because we're ending on a simple one, right? It's just splitting fractions. Right, so this actually comes in handy a lot, especially when you need to simplify stuff. So let's say we have something like 30 plus c over 6, right? What does this break up into? Well, the first thing, we'll get back to this problem. Let's learn how to split fractions first, right? So if you have, I'm going to give you 2 cases, a and b plus c, and a plus b over c, right? So if you're given a fraction like this on left, it's just you can't do anything about it. Unless you can factor something out of A to get rid of the B and C, there's nothing you can do. This is the form it's going to be in. But this, you can break it down by going A and C plus B over C. This is the same thing as writing A plus B over C, right? If I want to separate this fraction, I can do it like this. And the plus is irrelevant here. You can do A minus B over C, and you can get A over C minus B over C, right? So it doesn't matter. It can be plus or minus. So you just keep the denominator the same. Now you can't break this up. I've seen students go, well, this is the same as doing this, and it's not. That's not true. Or, let me make it more accurate. I've seen a lot of students go, this I can do, well, see, I'm doing A plus D, and I'm doing over B plus A plus D over C, right? And that is not good. You can't do that. Do not do that. Do not be tempted, because they will have answers probably like that on the SAT. They'll try to trick you and say, well, yeah, you could do it. Look. No. Unfortunately, it is not that easy. What you'll get, like again, it's A plus B over C, or A minus B over C. You'll get A over C plus B over C. Here you'll get A over C minus B over C. So this is okay. We can do this. Okay, so let's look at this, right? What's our A? A can be 30, right? What's our B? Or I guess our C. This is C. And then what's our, what would be our C, but it's going to be our B, right? So what do? We just keep the top here, right? So you would do 30 over 6 plus C over 6. Of course, this becomes 5, right? This whole thing here becomes 5 plus C over 6. That's it, right? So, boom, you got it. So you could be tempted by saying, I'm going to split them apart and get, something else, but that's not how that happens. Knowing these 5 techniques are going to help a lot. And that practice sheet I sent you guys has a lot of excellent problems, and I'm going to upload a solution video to them. So thanks for watching, and good luck in your sites.